In this example, we have to do somewhat the similar or the same thing that we did in the previous example. Describe a restriction on the possible values of x, except this time x is not just the length, the entire length of the third side, it's only part of it. So we still have to determine our borders. 10 plus 6 is equal to 16. 10 minus 6 is equal to 4. But now we have to do a little bit of algebra to find the final answer and the final value for x. Let's look back at our previous example where we determined that x had to be between 4 and 16. An algebraic way of writing this would also have been to say 4 is less than x is less than 16. So let's use this and start our work based on this over here. So now we're saying 4 is less than 2x plus 4 is less than 16. And this is a compound inequality that we can solve just like any other one. Solve it for x to get x all by itself. And the way we do it with compound inequalities is that the operation we're doing in all three sections of that inequality. First we need to subtract 4, get rid of that. Subtract 4 in all three sections. We get 0 is less than 2x is less than 12. And now we only have to divide by 2. And again, do it to all three parts of the inequality. Does nothing to the 0. In other words, 0 is less than x is less than 6. Or, in our own words, we can say the third side has to be between 0 and 6. That's that. Make a nice circle around it, and that's your final answer. Alright, so this type of knowledge we can use also whenever we have a situation where we don't have all the information. We can at least find out some stuff. You're standing 200 feet from a tall building. The angle of elevation from your feet to the top of the building is 51 degrees, as shown in the figure. What can you say about the height of the building? First of all, we need to recognize that we do have a triangle here, right? We have a triangle made up by our distance from the building, the height of the building, and the straight line that would go from the top of the building to back to us. We can also use our triangle sum theorem to determine the angles of this triangle. We have a right angle here. That means that the remaining angle we don't know has to be 90, which is what's left after deducting our right angle, minus 51, the given angle. So that would be 39 degrees. In other words, this angle here is 39 degrees. That's the smallest angle of the three, and that's across from the smallest side. 51 is the greater angle and 90 is the greatest. So we can say now, looking at our angle 51, which is across from a side that has to be more than 200 feet. From that we can determine that the building must be more than 200 feet tall. Now spend a few moments to think about what are other real-life examples of situations where you could use this type of knowledge, where it could be useful to determine distances, heights, other things like that. And after you have done that, go to your summary and in your own words describe how to determine the possible third side of a triangle given two segment lengths. That wraps up our lesson for today. Well done, guys, and I will see you in class.